Hello and welcome to Tangent Lines and Circles. Last time we were talking about just your basic terms when it comes to circles, your radii, your diameters, your chords, central arcs, central angles, arcs, arc measures, and arc lengths. Now we're talking about tangent lines. So we're still working with circles, and let's draw one to actually make this clear. We're actually going to draw it a little bit lower because we're going to put some definitions above it. And let's put this about to the side, kind of like that. And we're going to call this C for center. We would also call this circle C. And we could also, we're also going to put some other points here. I'm going to put a point here at the very, very bottom. I'm going to call this Y. Okay? Now, a tangent line. Now, tangent is the exact same term from when we talked about trigonometry tangent, or if you ever heard us, like you go off on a tangent, you are going in a direction and then you kind of just spilled off into a different direction. That's kind of what a tangent is, right? You got off on a tangent. Tangent to a circle has its own kind of specific definition because we're working with circles. It is a line or segment or ray, whatever, what have you, a line that intersects with a circle at exactly 1 point. Okay, so that's why we drew this Y here, because we're actually going to draw a line from left to right, and we want that to intersect at exactly that 1 point Y. Okay, so I'm going to draw some arrows here to make this a line. I'm going to draw some extra points here, and I'm going to call this X, and I'm going to call this Z. And we could say, for example, actually, let's put this underneath. Example, XZ is a tangent line. Is a tangent line to circle C. Because it intersects at P, or at Y, sorry. At point Y. So we could clearly see that there is only one point of intersection here, Y, and that line goes through, and that's where the intersection is. Okay, so that is a tangent line. It is a tangent to a circle. Now, there's also a theorem that goes along with this, because if you have a tangent line to a circle, then we have the tangent radius theorem. Now, the name isn't very important. What is important to know is the actual definition. Anytime you have a tangent line to a circle, a tangent line to a circle, is always going to be perpendicular to the radius at the point of tangency. Now, the point of tangency is the exact point we were talking about, Y. That is where the intersection is. Okay, so let me draw that Y somewhere else because that Y is in the way. Let's move this off to the right here, Y. Okay, now, since this is a tangent line, it will always be perpendicular. The radius that is CY is always going to be perpendicular to the tangent line XZ. Okay, and that's always going to be the case. So that's what happens. So for example, we could say XZ is perpendicular to CY at point Y. So that's the point of tangency. Okay, and let's move that Y down again because that's bothering me again. All right, but you get the idea. Hopefully you get the idea. At that point of tangency, we have right angles. That's the whole gist of it. Okay. Another thing we have is congruent tangent segments. Okay, anytime you have, so we're going to draw actually a new diagram. So we're going to draw one, for instance, right here. Okay. And I'm going to draw two different tangent lines. And that one doesn't quite look like a tangent line because you can see multiple intersections. There you go. That's a little bit better. Then I'm going to draw another one. Okay. I'm going to move only this part of it. So now we have point of tangency at two particular points. Okay. So what happens here is this. I'm going to draw a center, and we're going to call this O this time. So this is circle O. Draw some arrows. And here we have two different tangents on one circle. So we're going to call this the congruent tangent segments. And it's exactly what it sounds like. Anytime you have two tangent lines that share a common endpoint. So we're going to put an endpoint here. Okay, let's call this, for instance, A, B, and C that are around the circle. We're going to say if two tangent lines share a common endpoint, and I probably should have pushed this down a little bit for more room. Common, I have the luxury to do so. Move it down a little bit more. If they share a common endpoint, in this particular case, that common endpoint is B, because the two tangent lines are intersecting there. Then the two segments are congruent. So what this means is we have two tangent lines. Let's actually highlight them. I'm going to use red. So that's one tangent line. And then I'm going to do blue. Another tangent line. These are two separate tangent lines, and they both meet at B. When you have this, these two segments are going to be congruent. Okay? So this says, here's your example. If BA is and BC, I'm sorry, and BC are tangents to circle O, then BA is going to be congruent, the segment BA is going to be congruent to BC. And that's exactly what we have here. Okay? So those are the core parts to tangent lines. At least for now, we're going to be working with tangent lines a lot for the next few sections, and even secant lines, but we'll worry about that later. Tangent line, as we know, that the most important thing is that it intersects a circle only at one point. Okay? If you do have any questions, please ask, and I'll see you in the next one. Bye.